Welcome to our YouTube channel, guys. Today we are coming after a long time. So today I'm going to address a mathematical problem. These types of problems are often asked in competitive exams. Any competitive exam you might appear in, uh, whether it in any country, right? For example, in net exam in India, GATE in India, etc., or in any other country. You should be familiar with these types of problems so that you have an edge over the other students, right? So, what does this question ask? The problem says as follows: there is a square of size 6 centimeter with two of its adjacent sides as diameters, right? As diameters of what? As diameters of two circles as shown in the figure. Find the area of the shaded portion. So let me read it once again. There is a square of size 6 centimeter with two of its adjacent sides as diameters of two circles as shown in the figure. Find the area of the shaded portion. So you must now have understood this problem. So let us begin. So this is one shaded portion. This is the other shaded portion, another shaded portion. These, we have to find the area of these two shaded portions, right? We can simply find the area of this shaded portion and multiply it by 2, and then it will give us the answer, right? So what we'll do now is, first we'll find the area of this semicircle that I am showing you, this semicircle, right? This one, this semicircle, this one. How will we find its area? It's very simple. The side is 6 centimeter, right? So area of this whole circle is pi r square. Area of this whole circle is pi r square, equal to pi into 3 square. What is 3 square? 9. Pi into 9. 9 pi is the area of this circle. So the area of the semicircle is 9 pi by 2. Therefore, the area of this semicircle is 9 pi by 2. So, therefore, the area of one of the semicircles is SC's, I'll write, is 9 pi by 2. Centimeter square is understood already. It's the unit, right? So area of one of the semicircles is 9 pi by 2. So 9 pi by 2 is the area of the semicircle. So now let us see what we are going to do. So now what we'll do one thing. We'll join this point. I'll just show you which point. This point, and this point. We'll join these 2 points, right? This point and this point. We'll join these 2 points, right? Let us join them. The joining might not be perfect. Don't care about that. The thing is, we have to solve the problem. So we have joined these 2 points, right? and then what we'll do is we'll join this point, right, and this point. These 2 points will join. So we joined these 2 points, right? Let us name this point A and this point B, and let us name this point C, right? So now what we are gonna do, we'll find the area of this triangle ABC. The area of this triangle is half of base into height. So let me write that here. So it is 1/2 into, what is its base? It is AB. For example, what is AB? AB, this A, this B, this AB line segment. This is half of the side of the square. Means side of the square is what? This 6 centimeter. This is 3 centimeter. Half of 3 into height. The height is what? Height is this AC. AC is also 3. So the area is 9/2. So what we'll do now is we will just find the area of this sector. I mean this sector of the circle, this 1/4 of the circle, A, B, C. Not this triangle, but this sector, right? That is the line segment AB, line segment AC, and the arc BC. The area between these two lines and this curve, the area of this sector, 1/4 of the circle, we'll find that. Since the area of the circle is 9 pi, right? Area of the circle is 9 pi, so the area of this sector will be 9 pi by 4 automatically. So we'll just write it here. We'll write that here. So the area of this sector is 9 pi by 4. Now what we'll do is we'll subtract the area of this triangle ABC from the area of this sector. So we'll get the area of this thing that I'll just cross that area, right? Put some crosses on that area. We'll get the area of this thing, right? This is what? Kind of semi-lunar or something like that. So this crossed area, we'll get the area of this thing by subtracting the area of triangle from the area of sector. So by subtraction, what we get? What we have to do? We have to do this 9 pi by 4 area of sector. From this we have to subtract the area of the triangle minus 9/2, right? And we can take 1/2 common, is equal to 1/2 it becomes 9 pi by 2 minus 9. We could have taken 9 by 2 common also. Okay, we'll take 9 by 2 common, is equal to 9 by 2, but will remain inside the bracket, pi by 2 minus 1. So if we multiply this thing, the area of this thing, area of this by 2, we'll get the area of the whole this I-shaped thing, right? This, I'll cross the whole of the area now, right? So this area I'm talking about, these two crossed areas, we'll get the area of all of this if we multiply this by 2. So let us multiply this by 2. It will become what after multiplying, right? After multiplying, we get this 2 will get cancelled. We'll get 9 into pi by 2 minus 1, right? We got 9 into pi by 2 minus 1, but this is not the required area. The required area is the area of the shaded portion, this and this area of the shaded portion. So how will we get that? We'll get that by, we'll find the area of this thing first. We'll subtract this area, the area of this, this area, from the area of this semicircle. We'll get the area of one shaded portion. So let us do that. So what we'll do, area of the semicircle is 9 pi by 2 here. 9 pi by 2 minus 9 pi by 2 plus 1, right? Because I changed the signs because we subtracted this, minus 9 pi by 2 plus 1. This will become what? So this will become not plus 1, plus 9, sorry, I made a mistake, plus 9, right? So this will become what? These two will cancel, this will become 9. So 9 is the area of one of the shaded portions, right? So we are close to the answer. So area of the shaded portion, the total shaded portion is, we simply multiply this by 2, because area of these two is this and this is same. So therefore the required area is 9 into 2 is equal to 18 centimeter square. So the main thing in this problem was to find the area of this crossed portion, right? This was the main portion. The other things were very, very easy. And the other thing I want to share here is that is not necessary in this question, but in some of the problems you might need that thing or those things, that this angle here, this angle is 45 degrees. This angle, let me name this point as this point. Let me name this point as what? Let me name this point as O. Angle BCO is what? It is 45 degrees. You can prove this also by a number of methods. This is the radius of the circle. This is also the radius, right? Two radii, and equal sides are equal angles opposite to them. These two angles are equal. This angle CBO, right? This angle CBO, and angle OCB. Angle CBO and angle OCB are equal, and this is 90, so these two are 45. And by symmetry also, this looks like 45. And by other method, for example, the angle subtended by an arc at the center is double the angle subtended by it at any other part of the circle. For example, the arc, for example, let me name this D. The arc BD, it subtends an angle 90 degree at the center. The angle subtended by it at any other part of the circle is half of this angle. I mean, the theorem states that the angle subtended by an arc at the center, I mean by this arc at BD at the center, is double the angle subtended by it at any other part of the circle. Any other part means any part other than BD, right? So this part is that any other part, right? So the angle 90 degrees is double the angle subtended by the arc BD at any other part of the circle. For example, at this point, at any point, this arc BD subtends an angle 45 degree. Look how. Join this point here, point B to point C, point D to point C. This will form an angle 45. If we join point B to this point, for example, we join point B to this point, for example, here, any point, and point D to this point here. This will also be 45, right? So there are three methods to prove this is 45 degree. This was not part of the problem, so part of the answer was 18. You can skip this part, but these are also tidbits that you can use in other problems that of this type, right? So if you like this video, please give this a thumbs up, subscribe to our YouTube channel. This is only the beginning, and other such videos will come shortly, and God willing, other videos will come shortly. I'll be uploading videos related to physics and mathematics a lot in the future. So please subscribe to this channel, and you'll find this content helpful. And if you think your friends also need such content, please share it with them. So goodbye.